In this video, we'll complete our review of Chapter 2 by looking at 2.3, 2.4, and a little bit of bar graphs that will be in 2.5. You'll notice that I'm using the older PowerPoint. I have on Moodle a Chapter 2 PowerPoints folder, and also underneath that a review PowerPoint and something labeled the old Chapter 2 PowerPoint. Now, this is the old Chapter 2 PowerPoint, and you can use the new ones as additional review. They will be very similar. I actually prefer the older PowerPoints, but you have both of them that you can look at and use whichever one you feel is clearer to you. So in 2.2, we looked at how to organize our data by creating frequency tables or frequency distributions. And we set up classes and got our counts. And now we're going to use those counts, either the relative frequencies or the regular count frequencies, to create something called a histogram. And that is going to help us view the shape or the distribution of this data to see if it is indeed normally distributed or creating a bell curve. When we make a histogram, the bars are going to be touching each other. So no gaps. A bar graph has gaps. Histograms don't. I'm not terribly upset if you draw it without or with the gap or not with the gap. They do mean two different things. When they're touching, that means that there is no break in between that data, so that the data is continuous, something that we talked about in Chapter 1. If there's gaps, it means the data was qualitative, so maybe it's like your different flavor ice creams or cat, dog, fish, something that is just a title, or that the data is discrete. So we're going to look at a different frequency table for our histograms. And so I have pulse rates of females, and I have a lower class limit of 60. And an upper class limit of 69 for my first class, of which I have 7. And I can identify the class width by just subtracting these two values. So 70 minus 60 is 10, right? And it's the same the whole way down. You'll notice for the histogram on the x-axis or horizontal, they labeled it using the class boundaries. This is just a personal preference. Sometimes the textbook uses the class boundaries. Sometimes they use the class midpoint. That's what I prefer. You may use the lower class limit. If the problem does not specifically say label your x-axis using the lower class limit or the upper class limit, then you just get to choose. The y-axis or the vertical axis will always be the frequencies. So it's always going to be this count over here. So this is always going to be your x-axis. And this is always going to be your y-axis. And then you're going to choose an interval. They chose to go by 5. So you might want to go by 2, by 10, by 1. It depends on the data. And then you're just going to draw a bar up and make your graph. And now we can see that this distribution kind of looks like this. I have a slow little gap here, but not enough to really worry about. We can also draw it using a frequency, relative frequency, instead of a frequency that uses just a count. Those graphs very often look the same. You can see this one compared to this one. They almost look identical. And that happens kind of naturally just because of the distribution of the data, but you can manipulate it so that these look very different. You can see that these are spaced by 10s now, right? Where before we were going by 5s. They still use the class boundaries down here, but again, that's your choice if it doesn't say. Notice that it says relative frequency. Now sometimes they use the percents and sometimes they label it like 0.3, 0.2, 0.1. I prefer with the percent sign on it, but again, if it doesn't say, hey, use a percent sign, use it in decimal form, then it's up to you. The shape is really what we're looking for. We're looking that the frequencies increase, hit a peak or a maximum, and then decrease, and also that it is symmetric, with about half of it being to the left and about the other half, about half, being to the right. So something like this. You can see it's not perfect, right? My lower is a 10, and then over here is a 6. But this would be considered something that's normally distributed. That kind of peaks in right about in the middle and then works its way back down. So this would be a bell shape. And in stats, that means a normal distribution. There's other graphs that we can create. There's something called a frequency polygon, which I like to just say is kind of the lazy man's histogram. So instead of drawing a bar like this, they just made a dot and then connected the dots. Now, you need to anchor it at your origin, which should be a 0, and then the anchor out here to close it could either be at the end of the axis or it could be at the bottom of where you would have had the box. That's kind of negotiable, but it has to be closed. So there has to be a dot at the beginning on the x-axis and a dot at the end so that it closes this up, because a polygon actually has a special definition. It's a closed figure, and if you don't anchor it to the x-axis, then it's not closed. You can have a relative frequency polygon. You can have a multiple relative frequency polygon like we have here. You just have to make sure that you label what data is represented by which graph. Again, both of these are anchored to the x-axis. You can have an ogive, which we'll probably never see again after Chapter 2, which takes the cumulative frequencies, either the relative or the actual count frequencies, and draws out a relative, the cumulative frequency graph. So if we go back to the data, you'll see that I had 12 in the first, and then so my next cumulative would be a 26, right? And then my next cumulative would be a 37. And I can go ahead and draw that. So that I have 26, that's 37, and so that your very top one's going to stop at n, right? The number of data pieces you had. You don't close this one off, though. You just kind of leave it floating out there. It's one that we will not see a lot. The same rules apply for the labeling. It's whatever they say that it needs to be down at the bottom or whatever you choose, and that these y-axis can be whatever spacing that you choose. We have something called a dot plot, which is sort of like a histogram that doesn't use classes. So you would draw your number line, and for every little piece of data that you kind of imaginarily pull out of the bag, you make a little dot. So if I were to go into the bag and pull a 60 out, I would say, oh, okay, I got a 60, and make a little dot. It's kind of like, instead of a tally chart where you're keeping track with little marks, you make a little dot, and so that you'll see all of the data pieces specifically, so not a range, but you know that I have for a fact 3 60s, and I know 4 64s, and it makes this very long histogram, if you will, where it's kind of like a class of 1. We don't use dot plots a lot, even though they are a nice way to keep track of and show all of the data pieces, because they can take up a lot of space and a lot of time. More than likely, if you want to see all of the data pieces, but still keep it somewhat concise, we use something called a stem plot, which you may have called a stem and leaf plot. So your stem is that tens digit over here, and then the leaf is that unit that you would pick off at the end. So it's kind of like a frequency distribution table with a class width of 10. So these would be 60s, 70s, 80s, all the way up to wherever you need to stop. And then you would pull the leaf off and write it in here. So this means I have a 60, a 60, a 60, 1, 2, 3, 4 64s, and 5 68s. And if you kind of turn your head, you can see the same histogram that we had before. I really like the stem plot. My Labs Plus will, when they ask you to create it, will ask you to create it in numerical order, so 0s and then 4s and then 8s For me in class, I don't care if it goes 8, 4, 8, 0, 6. That doesn't bother me if it's in a different order. You can have multiple bar graphs. You can see that these aren't touching because it's male, female, right? So these guys are going to be qualitative categories. You can have something called a Pareto chart for qualitative categories, which for whatever reason they do put touching, but it just takes the one that had the highest count and puts it first and then goes in descending order. Descending. I don't know if I forgot how to spell descending. If they match, if you have two that are the same, then you just kind of pick your favorite of who gets to be first and who gets to be second. Again, we won't see a lot of Paretos, multiple bar graphs, dot plots. Dot plots take too long, and multiple bar graphs and Paretos are for qualitative, and we are quantitative, so we're going to be looking at numbers, not categories. Same thing with pie charts or circle graphs. These tend to be for things that are qualitative in nature. There is a process to how you draw these pie charts. It's something that we're not going to look at a whole lot. The hard and fast rule, though, for a pie chart is that when you label these, one, you label them with what they are, and it's also good practice to go ahead and put in what the percent is. But all of these percents have to add up to a sum of 100, not 110, not 90. It's got to be 100. Pictographs are something that we won't talk about much at all either, although we will need to have keys like a pictograph does for most of our charts. Scatterplot is a chart that we'll look at the very end of the course in Chapter 10, and you've probably seen these in your algebra courses a whole lot, where you have an XY value. So if something happens with X and it has some type of response Y, and then you plot it on the grid, and eventually what we'll do is we'll look for a line of best fit and how well that line hits all of those dots. Put this in the back of your mind because we won't see the scatter plots until the end of the course, and we won't work at time series graphs at all, although you probably see these a whole lot if you watch the news. It's kind of like an XY plot over time where we lock the time in down at the bottom. So if you watch like stock market stuff, you'll see an example in the bad graphs video about unemployment rates. Time series graphs are incredibly popular to be, on the news, but it's not something that we'll work with in the course. You want to have your data sets to have 20 values or fewer. And you certainly want to have less than 20 classes. The graph should be clear and not distort the data. So there's a set of rules that you should follow. You should always have a 0 here. Now sometimes we get lazy, we put in a break, and that's technically a no-no. But you can see that these two graphs say the same thing, but yet they look very different. You shouldn't have pictures in here because it's very deceiving. It kind of changes where your eye focuses. And never, never, never use a pictograph because it will skew exponentially the differences in the data. You want it to be nice, neat, clear, label, and even in the spaces and even in your intervals. Now on Moodle, there is a video that says examples of bad graphs. She is from the UK and uses several bad graphs from over here in the US to kind of point out some things that went wrong. There's a lot on Fox News, but that is not something that I chose. It's just kind of how it worked out. So after you watch this video, you might want to check out your examples of bad graphs. And that is the last video for Chapter 2.